Question number 2. Dina had 2.707 kilograms of flour at first. She used 459 grams of it. How many kilograms of flour was left? So in this case, we know that 1 kg is 1000 grams. So 2.07 kilograms would then be 2070. So basically 2.07 times 1000. This will give us 2070 grams. So the next thing is, which is how much are we left with? So in this case, what we are left with is basically 2070 minus 459, and this will give us 1611 grams over here. That's it. Question number 3. The line graph shows the growth of plants over 4 weeks. What was the percentage increase in the height of the plant from week 1 to week 3? So in this case over here, if you were to zoom this in, we want to know, first, this is a graph, right? So we want to know the number of gaps in this. So if we were to zoom it in all the way, we see that over here we have a couple of gaps. We have 1, 2, 3, 4, and 5 gaps. So this is 5 gaps, which is equal to 10 centimeters. So one gap will be pretty straightforward, which is 10 divided by 5, and this will give us 2 centimeters. So now we know what is one gap. The next thing is we want to find out how many is in week 1 and in week 3. So in week 1 over here, okay, we can trace out week 1. So for week 1, it is, in this case, 10 with 2 gaps. So that means week 1 will then be equal to 14. So let's go to week 3. So for week 3, if you were to, create the line, and then we mark out in the graph over here, this will give us 50. Then we have 1, right? 1, 2, and 3. So that means for week 3 over here, this will give us 56. So lastly, to get the percentage increase, we need to get what was the growth from 14 to 15, 56. So that means the difference, or I would say the growth, will then be 56, not divide, but minus 14, and this will give us 42. So let me just write here, height increase. So we want to find the height increase not in centimeters, but in the percentage over here, which in this case will then be basically the height increase in centimeters, which we have calculated over here. And then we divided by the week 1 height, not week 1, yes, week 1 height. And then we multiply by 100%. Pretty straightforward. So this will then be equal to 42 divided by 14. Okay, so you can put this, or just put here divide, and then times 100, and this will give us 300%. So the answer is 300%. Question 4. Triangle ABC is an isosceles triangle that lies within a figure made up of a semicircle and a rectangle. AB is equal to AC. Find the area of the triangle ABC. So if we were to zoom this in over here, to find the area of triangle ABC, we need to half times base times height. So we know that the base over here is 15 centimeters, which is this part. Pretty straightforward. So we know half times base. So half times base is 15. So what about the height, which in this case is over here? So we first know that this is 9 meters. Okay. Then we need to find out what this length over here. I'm going to put this double question mark. So the thing is that for this 15 meters over here, if I were to mark it out in green, this 15 meters is also the same length as what we see over here, which is basically the diameter of the semicircle. So for the diameter of the semicircle, we also know what is the radius of the semicircle. So in this case, since this diameter is 15 meters, so half of this will then be 15 divided by 2, which is equal to 7.5 meters. So that means this over here is 7.5, what we see over here. And since this is 7.5, that means the diameter of this side also is 7.5 as well. So with that said, since this is 7.5, that means this is also 7.5. So with that said, the 9 meters is also included in the height of the triangle. So that means the height of the triangle is 9 meters plus 7.5, which give us 16.5 meters. So if we were to look back of the area of the triangle ABC, since we know the height of the triangle, we will just put 16.5 meters. And this will then be equal to 123.75 meters square. There you go. Question number 5. The figure is formed using two squares and two equilateral triangles. The perimeter of the figure is 120 centimeters. PQ is a straight line. What is the length of PQ? So, if you were to zoom this in, let's call these two figures small and big, right? Like a small house and a big house. So for the small house over here, since this is a square, as what we see over here, then that means all of the sides are the same. And since it also has an equilateral triangle, that means this side is also the same. Does that mean for the big house, it is also what we went through for the small house? Yes, it is. So that means this is a square. And since this is, or this side is the same as the equilateral triangle, that means all of the sides are the same over here. So we want to find the length of PQ, which means it's basically this line over here. So this line plus this line over here. So how do we then get these two lines to get the length, right? PQ. So the thing is that we can say PQ is equal to one small side and one big side. Do we know what is the perimeter of all of the sides or these two houses? Yes, we do. From the question, it says the perimeter of the figure is 120 centimeters. That means if you were to count, for example, we have 1, 2, 3, 4, and 5 sides. And also in the big 1, 2, 3, 4, and 5 sides as well. That means 5 small sides and 5 big sides is equal to 120 centimeters. And since PQ is just one small side and one big side, that means we can just divide this equation to 5. So one small side plus one big side will then be equal to 120 divided by 5, which is 24 centimeters. And that is the length of PQ. Question 6, Part A. A group of students were asked to choose their favorite fruit in a survey conducted. The result was represented in the pie chart. Half of the number of students chose mango or orange as their favorite fruit. What fraction of the students chose apples as their favorite fruit? Express your answer in the simplest form. So we know from the question it says half of the number of students chose mango or orange as their favorite fruit. So this means that mango plus orange is equal to half. And what is half in percentage? If you guess 50%, then you're right. So you just put half times 100%, and this will be 50%. Therefore, that means mango and orange is 50%. So now we know the percentage for mango and orange. The next thing is we want to find the apple percent and then convert it into a fraction. For the apple, pretty straightforward. If you can guess, apple is basically the whole pie, 100%, minus half of it, mango and orange, which is 50%, minus the pear, 35%, and we will get 15%. And what is apple in fractions? It's basically 15% or 15 out of 100, right? And then if we were to simplify, this would then be equal to 3 out of 20. So the answer is 3 out of 20. There you go. So remember, 15% go to 15 out of 100. The question 6, part B. So this is a true, false, or not possible to tell question. half of the number of students chose mango and orange as their favorite fruit. So, according to this statement, more students chose orange than pear as their favorite fruit. So, we know from the question, mango or orange, and you can refer to the pie chart as well, we know that this is half of 50%. So, if you were to convert it, and we want to find out mango, because if we find mango, we are able to find orange. So mango says here is 1/5. So what is 1/5 in terms of percentage? So that means 1/5 is basically 20%, or 1/5 times 100%, which is 20%. So that means for mango, it is 20%. So since we know mango is 20%, that means we can calculate orange, which is basically 50 minus 20, which is 30%. And the thing is that we know from the pie chart that pear is 35%. Okay, since pear is more than orange, this statement is false. In this case over here. Okay, for the next true, false, or not possible to tell statement, more students were surveyed and all of them chose mango as their favorite fruit. The percentage of students who chose apple remained the same. So do you think this is true, false, or not possible to tell? So the thing is that if we were to say that original, so for example, let's take total students as 100 students, right? So that means since mango in percentage is 20%, then mango would then be equal to 20% times 100, which will give us 20 students. Same goes with the apple, right? So for apple percentage, it is 15%. So that means it will be 15 students. So now it says more students were surveyed and all of them chose mango as their favorite. So let's say new students are 20, or let's say more students are 20. So that means the total number of students over here would then be equal to 100 plus 20, which is 120. And then they chose what? What did they choose? They chose mango as their favorite. So we know before mango is 20, then it will add another 20. This will be 40. Okay? So, but that's not the case, right? What we want to prove is the percentage of apple remained the same. So that means the new apple percentage over here is equal to 15 out of the new total student 120 times 100, which is 12.5%. And the thing is that the apple at first is 15%. So that means percentage of students who chose apple did not remain the same. So therefore, this is false. So next, true, false, and not possible to tell statement, which is 20 students chose mango as their fruit. So the thing is that since we don't know the total or any number of students for any fruit, we can't say it's the 20. So that's assuming, right? There is no part that it says, oh, there is number of students equal to 20, even though the mango is 20%. So this is hard to tell. So it's not possible to tell. Question 7. Figure 1 shows an empty container with a rectangular base of 30 centimeters square. Then the container was filled with some water. Figure 2 shows the front view of the container, and figure 3 shows the container turned upside down. What is the capacity of the container? So this is a tricky one. So what I'm going to show you before we go through this question is a simple example. So let's say we have this container over here. Okay, so for this container, it has some water. So we also know that we're going to split these two parts into A and into, in this case, B. So now the thing is that if we were to flip this container upside down as what we see over here, just like what we see in this, what they call this, statement or question over here, then this A over here might have a different, I would say, height, but is the volume the same? So in this case, if the total volume is equal to 30 ml, right? I'm going to use ml, and A is equal to 10 ml, and B is equal to, can you guess? 20 ml. So no matter how they are placed, the volume remains the same. Does that make sense, right? So no matter what, the liquid will always be the same number of volume. So I see over here. Okay. So in that sense, we know that the volume of the water will remain the same over here as well. So if A is the volume of water here and B is the air, that means A is also the same here and B is also the same over here, no matter what the size is. So that means we can actually find the capacity of the whole container. So the total capacity would then be equal to A plus B. So to get the total capacity for A, which is in figure 2, in this case it is 4.6 times 30, or you can just put 30 times 4.6, right? And what is the formula or the equation to this? It's basically the base area times height to get the volume. So in this case, this would then be equal to 138 centimeter cube. So for B over here, how do we then get B? So to get the height of B, or B height in this, we also know that this is 7.8 centimeters, right? So that means if this is 7.8, so what is the height for B? Since the area of B also is the same, right? The base area is the same. So that means height of B in figure 3 is basically 7.8 minus 5.5. And this will give us 2.3 centimeters. Okay, so once we know the height, then we can get the volume of B, okay, in figure not 2, but 3. So that means it's 2.3 times 30. So same thing, right? Base area times height. So the base area is 30 times 2.3, and this will give us 69 centimeter cube. Since we know volume A and volume B, so that means the total capacity would then be the total of 138 plus 69, which is 207 centimeter cube. And that's the answer. All right, question 8a. JKLM is a rhombus. KLN and KLO are triangles. LM is equal to MN. Find angle LOK or angle LOK. All right, so with this kind of question, you always want to work backwards. So LOK in this case over here is this red angle. Okay, so how do you find this red angle? So this red angle is actually part of this big triangle as what we see over here. So that means to get angle LOK, we have 180 minus LKJ. Let me just highlight this in green. And OLK, let me highlight this in blue. Okay, so let's find out angle LKJ, which is in green. So how do we know what is the angle for LKJ? So the thing is that we actually can find angle LKJ. So let me highlight this part because JKLM, which is in this purple over here, is a rhombus. And since we know this part of the angle is 72, that means we can get the adjacent angle, which is LKJ. And in this case, it's basically 180 minus 72, and this will give us 108, which is the adjacent angles in rhombus. That adds to 180. So that means this green angle over here is not 180, sorry, but 108. So now we know that angle. The next thing is we want to find out this blue angle over here. So how do we find this blue angle? to find out this blue angle, we basically need this big angle over here, MLK, and then minus 21. So to find the OLK, which is the blue angle, that's what we see over here. So MLK is black, right? Okay. So how do you find MLK? If you were to look closely again, that's 72 degrees. This whole thing is also 72 degrees because opposite angles are the same in the rhombus. What we see over here. So MLK is the same as MJK because opposite angles are the same in the rhombus. So that means for OLK, the blue angle that we're looking for, it's basically 72 minus 51. Sorry, 72 minus 21, which is equal to 51 degrees. So this will be E1. So now we know the two angles that we need to find LOK. And we can just go through the equation again, which in this case would then be equal to 180 minus 108 minus 51. And this will give us 21 degrees. There you go. So that's the answer, 21 degrees. Let's move on to part B. So question 8, part B. JKLM is a rhombus. KLN and KLO are triangles. LM is equal to MN. Find angle LNM. So what is angle LNM? Is this angle over here in red. So if you were to look closely for LNM, what kind of shapes is it part of? So if you were to look at the question, LM is equal to MN. So let me just highlight that. LM the same as MN. What you see over here. So that means this triangle is an isosceles triangle. Which means that to find LNM, it is basically 180 minus angle NML, which is, I'm going to put this in pink. See the pink? Okay, or put in black, right? Like this. So for NML, how do you find NML? So if I were to highlight this line over here, angle NML is basically 180, which is the line, minus this angle over here, which is in purple, which is LMK. So for this LMK over here, we need to find what are the two other angles, which is this purple angle and this green angle. What I see over here. Why? Because this is a triangle, right? As what you see over here. So that means for LMK, it is basically 180 minus MLK, which is in, it is not purple, sorry, blue. Okay. So the LMK in blue is equal to MLK, which is in purple, minus MKL, which is in green. So we need to find these two angles, MLK and MKL. So actually we can find the purple angle first. So if I were to just focus on the purple angle, we also know that this whole thing over here is a rhombus. So that means MLK, it's basically the same as MJK, which is in this case is 72 degrees. All right. And lastly, we want to find this green angle. And if you were to look closely, the line splits this rhombus into half. So, which means that MKL is LKJ, which is this whole part over here. And then we divide it by 2. So for angle LKJ, let me put it in orange. And since this is a rhombus, for angle LKJ, it is basically just 180 minus 72, which is the adjacent angle. And this will give us 108 degrees. And with that, we can divide this by 2. So MKL is half, right? So MKL is the green angle divided by 2. And this will give us 54 degrees. Okay, since we know the angle for these two, green and purple angle, we can finally get the purple angle, which is LMK. So for the purple angle, we just have 180 minus 72 minus 54, and this will give us 54 degrees. And since we know this is 54, that means we can find this black angle, which is NML, which is 180 minus 54, and this will give us 126. Since we know this angle is 126, that means we can find angle L and M, which is basically 180 minus angle NML, which will then be equal to 27 degrees. That's what we see over here. Okay, so there you go. This is 27 degrees. Question 9. I read part of a book in the morning. The ratio of the number of pages he read to the number of pages that were unread was 6:5. So reading another 195 pages of the book in the afternoon, I still had 10% of the book unread. How many pages were there in the book? So this is a typical ratio problem. So from the question, it says the ratio of pages that is read to unread, it was 6:5. So we're going to type here 6 and 5 over here. Then the next part is what has changed after reading another 195 books of pages in the afternoon. So that means he read 195, but that also means that the unread over here is minus 195 because it is the same number of pages in one book. And lastly, Kai still had 10% of the book unread. So if total pages is equal to 100%, and then unread is equal to 10%, that means read is equal to 90%. So with that, we can say unread or read is to unread is 90 is to 10. And we simplify it to 9 is to 10. So I see over here. So we can write here 9 is to 10. Okay. And the thing is that if you were to look closely over here, since the total pages are the same, that means we have a total line over here. So total would then be equal to 11. And, the unread over here is not 10, it's 1. So this is 1. So that means the total here is 10. So which means we need to make the total the same. We need to get the lowest common multiple of 11 and 10, which is 110. Sadly. So with that said, we need to change this whole thing into the total of 110 as what we see over here. So how do we get 110? From this is basically 11 times 10, which is 110. So that means we need to multiply 10 for each of our numbers here. So 6 times 10 is equal to 60. Then 5 times 10 equal to 50. Then we're going to do for the after as well. So this is 9 times 11 because in the total it is 10 times 11 is 110. So that means 9 times 11, and this is 1 times 11, which is equal to 11. So therefore, the difference in units will then be equal to, for example, 99 minus 60, and this will give us 39. And difference in pages will then be 195. Therefore, we will have 39 units is to 195. That means 1 unit will then be 195 divided by 39, which is 5. And lastly, how many pages were there in the book? So that means the 110 units, which is the total, will then be equal to 110 times 5. And this will give us 550 pages. There you go. Question 11a. A fruit seller had some mangoes. He sold 2/5 of them and donated 104 of them. He was left with 1/3 of mangoes and packed them into 24 bags. Some bags contained 4 mangoes each, while the rest contained 6 mangoes each. How many mangoes were packed? So we know that we sold 2/5 of it, and what we are left with, and donated 104, right? And what we are left with is 1/3. So we know that the total is just 1 whole, right? 1 whole. So that means donated in terms of fractions, which will be equal to 1 minus 2/5 minus 1/3. And this will then give us 1 minus 6 out of 15 minus 5 out of 15. And donated in fractions will be 4 out of 15. We also know that donated is also equal to 104, because that's what the question says. That means 4 out of 15 mangoes is equal to 104. Then 1 out of 15 mangoes will then be equal to 104 divided by 26. 4, sorry, equal to 26. So the next thing is we want to find how many mangoes were packed. So in this case, we know that the packed one was what's left. So that means the packed is what left, which is 1/3. And we want to convert it into denominator of 15 because that's how we got our mangoes. So that means 5 out of 15 mangoes is basically 26 times 5. And this will give us 130. All right. Question 11, part B. How many bags contained 6 mangoes each? So earlier, we know the numbers of packed mangoes is 130. So we're going to use assumption because we have 2 values, 4 mangoes and 6 mangoes. We also know the total. Okay, so with that, step 1 is we want to assume all bags contain 4. So assumed total will then be 24 times 4, which is 96. Then step 2, we want to find the difference. Find the difference. So that means the total difference is basically the actual difference, which is 130, minus the assumed total 96, which is 34. And then we will need to find the other difference, which is the value difference. So the value difference would then be 6 minus 4, which is equal to 2. Lastly, we want to divide, since our assumed total contains 4 mangoes, right? So that means when we divide, we actually can get the number of bags of 6 mangoes, which in this case is basically dividing the total difference divided by the value difference. And that is equal to 34 divided by 2. And this will give us 17. And that is the answer. Question 12, part A. The figure is made up of 4 identical quarter circles, 2 identical squares of sides 14 centimeters, and a rectangle of breadth 19 centimeters. 4 identical semicircles lie within the figure. Find the perimeter of the unshaded part. So which one is the identical quarter circles? So this is the quarter circles that they are referring to. It's highlighted in red. That's what you see over here. So this is the quarter circle. So the thing is that to find the perimeter of the unshaded part, it is basically, let me highlight it in blue. So the unshaded part is this 1, 2, 3, and then we have 4. So 4 semicircles. And then at the same time, we also have this 19 centimeters, right? The unshaded part. Obviously, okay. So perimeter of unshaded part is basically 19 plus 19 plus 4 times of semicircle, which is basically 38 plus, what's 4 times semicircle? 2 full circle. So to get the 2 full circle, what we need to do is we need to get the diameter of the semicircle over here. So to get the diameter of the semicircle, we know that this is 14 centimeters. So you see over here. And this is a square. There you see, 2 identical squares. So which means this is also 14. Which also means that this is a quarter circle, like we mentioned earlier. So that means if this is a 14 or the radius is 14, that means this is also 14. That's what we see over here. Then we need this little last part, okay? And since we know this is 14, right? Okay, so we know this is also 14 because if we just move down, this is 14. And this little purple part is just basically half of it. I'm gonna put this here. So since 14 is half of this, that means this is 7 centimeters. With that said, the diameter of the semicircle, it is 14 plus 7, which is 21. Then we can find the radius, which is basically half of 21, which is 10.5. So since we know the unshaded part, we just need to get 2 full circle, right? Which is basically equal to 2 times height times radius. In this case, it's equal to 4 times 3.14 times 10.5. So 2 times 2 is 4 lah. 3.14 times 5. And this will give us 131.88 for the 2 full circles. Now, we can just add them up. So we know that the parameter of the unshaded part is basically 38 plus the 2 full circle, which in this case will give us the final answer of 169.88 centimeters. Question 12, part B. The figure is made up of 4 identical quarter circles, 2 identical squares, and sides 14 centimeters, and a rectangle breadth 19 centimeter. Find 4 identical semicircles lie within the figure. Find the area of the shaded parts. So pi is 3.14. So to get the area of the shaded part, we need to first get this whole, I would say, thing. Okay, what do I mean by this whole thing? So we get 1 quarter radius, quarter circle, and then we have another quarter circle, what we see over here. And then lastly, we have another square. That's what we see over here. Okay, so once we have that, then if we find this whole, I would say, area, then we can find, okay, this looks better. So then we can find the semicircle, and then we just minus off the unshaded semicircle to get the shaded part. Then once we find one shaded part, then we can find 2 shaded parts, which is the total shaded parts. So essentially, in summary, we basically need to find 2 times of the quarter circle, which in this case is this 2. And then we get the square area, total it up, minus 2 times of the semicircle, which essentially is basically equal to 1 semicircle, the big semicircle, plus the square, right? Minus 1 full small circle, what we see over here, right? Like this, okay? But essentially, in equation form, yeah lah, it's easier lah to calculate. That's what we see over here. Okay, so with that said, we can just calculate. Okay, so for the bigger circle radius, which in this case, if you were to figure it out, it is 14 centimeters. So if you were to put here as 14, so it's over here, then this will also be 14. So the bigger circle radius, which is in red, is 14. How about the smaller circle radius as what we see over here? Okay, so since this is 14, square is 14, right? Okay, the square is 14. Then since it's the quarter circle, which is also 14, the radius is 14. So that means this is also 14. Okay, because the quarter circle has the same radius. Then at the same time, we need to find this last part. Okay, so we see over here. And this is basically half of what we're looking for. Maybe put in yellow, so it's easier to see. Okay, so it's half of 14. So that means the diameter of this semicircle, so this is half of the 14, as what we see over here. So that means this is 7. So the diameter of the semicircle would then be equal to small semicircle in blue. Then B is 14 plus 7, which is 21. So the small circle radius, 2, it's equal to 21.2 divided by 21 divided by 2, which is 10.5. Okay, so that means this whole diameter over here we know is 21. So I see over here. Okay, so we can know the small circle radius. So now with that, we can find one semicircle, the bigger one is in red. Basically half times radius times radius. So we know the radius of the big semicircle is 14. what we see over here, 14. This will give us 307.72. Once we are done with that, then we want to find out one full circle small, which will then be equal to height times radius and radius. Since we know the radius of the small circle is 10.5, then the answer to that will be 346.185. Lastly, we need to get a square, which is this over here. Then we can just have the square, which is basically side times side, and that will give us 196. So that means we can find one shaded part, which is what we shared before. One semicircle plus square minus one full small semicircle, which give us 157.535. But it is only one shaded part. So we need to find two shaded parts. So we just multiply it by 2 over here. Okay, we need to find the bottom one, right? And this will give us 315.07. Okay, there you go. So that's the answer. Question 13, part A. Two rectangular tanks, tank A and B, are shown below. At first, tank A was 1/3 filled with water and tank B was empty. What's the volume of water in the tank A first? So we know that 1/3 of the height of tank A is basically 1/3 times 36. See over here, 36. This will give us 12. That means volume of water in tank A is basically the height or 1/3 of the height. So it will be 48 times 20 times 12, and this will give us 11,520 centimeter cube. Right, there you go. All right, let's move on to the next part. Question 13, part B. Two rectangular tanks, tank A, B, are shown below. At first, tank A was 1/3 filled with water and tank B was empty. Both taps were then turned on at the same time. Water from both taps flowed at the same rate of 2.4 liters per minute. How long did it take for the height of the water in both tanks to be the same? So first, we want to use height increase per minute. Okay, because we are looking for the height of water that are the same. So to get the height for each tank, we need to get the base area. So let's find tank A base area, which is basically 48 times 20, and this will give us 960. Then let's go to tank B to get the base area. It's basically 60 times 10, and this will give us 600. So now we know the base area. The next thing is we need to find the height increase per minute. So we also want to convert the liters into milliliters or cm cube, right? 2.4 liters is 2,400 centimeter cube. Okay, so now we know that we want to find the tank A height increase per minute. Okay, so because we know the base area, that means volume divided by base area, and the volume in this case is 2,400 divided by the base area 960, and this will give us 2.5 centimeters height increase per minute. So we're going to do the same for tank B. So tank B, since the water is the same, right? That means we can divide same, which is 2,400 divided by 600, which is the tank B base area, and that will give us 4 centimeters per minute in terms of increasing, as what I see over here. So now we know what is the height increase for both height increase rate for both tank. The next thing is we want to, because we know that there is a certain amount of time that both of the height are the same. So we can actually just put 1 unit with the number of minutes when the heat are height. HE, height of the tanks the same. So when the heights are the same, that means for tank A over here, right? So tank A, 1/3 height, basically 1/3 times. So what's the height over here? 36. So 1/3 filled, basically 1/3 times 36, it will be 12. So that means tank A volume when height the same as tank B will be equal to 12, then plus, then we know the rate 2.5. Okay, earlier we see 2.5 centimeters, times 1 unit. And this will give us 12 plus 2.5 units. Then tank B volume and height the same as tank A. So this is B, tank A. And then B equal to, since we know the rate is 4 centimeters per minute, then we just put here 4 times 1 unit equal to 4 units. And the thing is that since, so not tank A volume, tank A height the same as tank B, then tank B height the same as tank A. Okay, sorry. Okay, so since tank A height same as tank B, so that means 12 plus 2.5 units equal to 4 units. Okay, if we were to simplify this equation, this would then be 1.5 units, which is equal to 12. Then 1 unit would then be equal to 12 divided by 1.5. And this will give us 8 minutes. There you go. So that's the answer, 8 minutes. Okay, so this is a bit of a tricky one. All right, but once you get it, or once you practice a little bit more, then yeah. Question 14a. In the figure, ABCD is a square, ABE is an equilateral triangle, and DECF is a trapezium. DE is parallel to FC, and FDA is a straight line. Find angle DEC. So DEC over here is this red angle. So how do we find angle DEC? So to find angle DEC, we need to actually first find this other angle. So DEA, which is in green, minus this angle AEB. Then the last angle, which is in purple, CEB, right? Or BEC. So angle DEC is basically 360 minus all the angles as what we see over here. Okay, so let's find out the simplest one first. So for angle AEB, which is in black, we know that from the question, it says here that ABE is an equilateral triangle, which is in this case over here is this one, right? AEB, an equilateral triangle. So that means AEB is basically equal to 60 degrees. Okay, pretty straightforward. Then we move on to the next one, which is angle DEA, which is the green angle. So we also know that ABCD, I'm just going to highlight in red, right? So this, right, DA, AB, DABC, ABCD, sorry, ABCD is a square, right? So that means this is also all equal sides, what you see over here. And AED, since DA is equal to EA triangle, DAE is an isosceles triangle, which makes angle DEA, which is in green, equal to 180 minus DAE, which is in blue over here, right? So how do we find DAE? So we know that angle EAB is also 60 degrees. And we know angle DAB is 90 degrees, which is in red over here. So that means angle DAE is equal to DAB minus EAB. In this case, is equal to 30 degrees. Since angle DAE is 30, that means angle DEA is equal to 180 minus 30 divided by 2. And this will give us 75 degrees. So since angle DEA is the same as angle BEC, because they will have the same steps, if you were to do it, then that means angle DEA will be equal to angle BEC, which is also 75 degrees. Therefore, DC would then be equal to what we have calculated, and it will then be equal to 150 degrees. Question 14b. In the figure, ABCD is a square, ABE is an equilateral triangle, DCF is a trapezium, D is parallel to FC, and FDA is a straight line. Find angle DFC. So if you look to the figure, angle DFC is highlighted in red, as what we see over here. So how do you find angle DFC? Since we know that DFCE is a trapezium. That means we can actually find out the angle FDE, what we see over here, since this is a trapezium. So angle DFC is equal to 180 minus angle FDE, because the adjacent angle in the trapezium is a total of 180. So how do we get angle FDE? Since FDA over here is a straight line, that's what we see over here, that means we can get angle FDE is equal to 180 minus angle ADE, which I'm going to highlight it in blue, what we see over here. So how do we get angle ADE? All right. So in this case, we know that this triangle over here is a equilateral triangle. So that means this is equal. What we see over here. Then we also know that, I'm going to highlight this. This whole thing over here is a square. Means this angle is the same. This line is the same, and this line over here is the same. Can you see something? If you were to say that this triangle over here is an isosceles triangle, then you are right. But since DA is equal to AE, triangle DAE is an isosceles triangle. So to find ADE, basically we just have angle ADE equal to 180 minus angle DAE. So DAE over here will be this one, which is in pink. So how do we find angle DAE? So angle DAE is part of the corner of the square, which is this part, and then also, which is the right angle, minus this angle EAB, or in black. So the thing is that find the angle DAE is basically DAB, the red square, minus angle EAB, which is in black. Since DAB is the corner of a square, that means this is 90 degrees. And then for EAB, it's basically 60 degrees because it is a angle in an equilateral triangle. So that means angle DAE is equal to 90 minus 60, and this will give us 30 degrees. Since we know this is 30 degrees, that means angle ADE over here would then be equal to 180 minus 30 divided by 2. Then this will give us 75 degrees for this blue angle. Since we know angle ADE, that means we can find FDE, which in this case is basically just 180, which is the straight line, minus 75, and this will give us 105 degrees. And since this is 105 degrees and it is in a trapezium, that means angle DFC that we are looking for is basically 180 minus 105, and this will give us 75 degrees as what you see over here. Right, there you go. So that's the answer, 75 degrees. Question 15, part A. Several used rods to form figures that follow a pattern. The first 4 figures are shown. What is the difference between the number of rods used for figure 7 and figure 9? So in this case, let's look at the table rather than the image as what we see over here. So the table has some patterns. So if I were to write this down, figure 1 is 7 rods, figure 2 is 10 rods, 3 is 12, 4 is 15. So if you were to see a slight pattern, you could see that this is plus 3. And then after that, 10 is to 2 is plus 2. And then after that, this is plus 3 again. Okay, so it alternates, I would say, plus 2, plus 3 in this case. So the pattern is plus 2 and plus 3. So we're just going to brute force. So we're just going to continue. So that means figure 5 over here is basically 15 plus. Then we go to figure 6, so 7 and 9. So figure 7 and 9 is actually very close to our example. So figure 6 is 20. Then you just continue again. Figure 7 is 22. And then figure 8 is basically, you guessed it, 25. And lastly, for figure 9 over here, this will then be equal to 20. So we know figure 7 and figure 9. That means we can just get the difference between figure 7 and figure 9, which in this case is 27, figure 9, minus figure 7, which is 22. This will give us 5. There you go. So if you have figures that are small, you can just brute force or just literally calculate as what you see over here. But make sure you know the pattern. So question 50b. So Selvi used rods to form figures that follow pattern. The first 4 figures are shown. How many rods would she use for figure 99? So for this kind of pattern, generally you can use the image as a reference, but I generally just look at the numbers. So in this case over here, can you see what are I would say the pattern, right? So the patterns are basically from 7 to 10 is plus 3, 10 plus 10 is to 12 is plus 2, then 12 is to 15 is plus 3. So at the same time, if I were to continue, because this is part B, right? So I have all the figures from part A, and you could see this pattern. So the thing is that usually when you see alternate patterns, it's usually like odd and even. So if I were to just go from the question, since 99 is an odd number, I will pull out the different figures that are odd. So which in this case is basically figure 1, 3, 5, 7, and 9. So the next thing is, if you were to look at the patterns over here, you could see that from 3, we have 7 plus 5 is 12. Then from figure 5 is 17. So we just plus 5 for each of the odd ones. Since we know it's plus 5, you can have a guess that then we need to multiply it by 5. So for figure 3 is 1, figure 5 is 2, figure 7 is 3, and figure 9 is 4. So how do we do this? So in this case, to get the multiples, to multiply by 5, that means we need to divide it by 2. So in this case, figure 3 divided by 2 is 1. Figure 5 divided by 2 is 2. Figure 7 divided by 2 is 3. Figure 9 divided by 2 is 4. Okay, so that means if you were to get 99 divided by 2 is 49, remainder 1, which is 49. So that means for figure 99, we will then just have the equation 7 plus 5 times 49, and this will give us 252 rods. Okay, there you go. A little bit of a tough one. Question 16a. 3 girls, Mabel, Candy, and Lillian, had the same number of coins. Mabel had only 20-cent coins. Candy and Lillian each had a mix of 20-cent coins and $1 coins. Candy had 36 $1 coins, while Lillian had 13 $1 coins. Of the 3 girls, who had the least and who had the most amount of money? Okay, so in this case, we can use this. Let's assume each person has 40 coins because each person has the same number of coins. So for Mabel over here, we just have 40. Since she only has 20-cent coins, we'll multiply it by 0.2, and this she'll give us $8. Okay, let's move on to Candy. So Candy, we want to find the number of 20-cent coins. Since we know that Candy had 36 $1 coins, that means we can get the 20-cent coins, which is basically 40 minus 36, and then we get 4 20-cent coins. So that means for Candy, we will just have the total, which is 36 times $1 plus 4 times 20 cents. This will give us $36.80. Let's move on to Lillian. So can we get the number of 20-cent coins for Lillian? Yes, we can, because we have 13 $1 coins. So that means we have 40 minus 13, and this will give us 27. So lastly, for Lillian, we get a total 13 $1 coins plus 27 times 20 cents, and this will give us $80.40. So from here, if we were to pull out all of the different totals, if each of them has 40 coins, then we will know that Mabel is $8, which is the lowest. Candy has $36.80, which is the highest. And Lillian has $18.40, which is in the middle over here as well. So the thing is that, does this work for any number? So if I were to say if each person has 50 coins, I'm just gonna share the whole thing. Okay, so if each person has 50 coins, then we will just calculate. So Mabel will have a total of $10. If you were to calculate Candy, she has 38 and 80 cents, and Lillian has $20.40. And therefore, it will give you the same answer. Mabel is lowest for $10 and Candy has the highest for $38. Therefore, it is the same as what we have went through before. Okay, so for part B, Candy used half of her $1 coins and some of her 20-cent coins to buy a book that cost $20.40. How many 20-cent coins did Candy use? So we know that Candy has $1, 36 $1 coins. So she said from the question she used half. So $1 coins used in the book is basically half of the 36, which is 18. Then this will give us the remaining of the book cost, which is $20.40, which will then be 20.40 minus 18 times $1, which will give us $2.40 in this case over here. So now we get the remaining or the total value of 20-cent coins. So we can find the number of 20-cent coins used in the book, which is $2.40 divided by 20 cents, and this will give us 12. There you go. All right, question 16, part C. Three girls, Mabel, Candy, and Lillian, had the same number of coins. Mabel had only 20-cent coins. Candy and Lillian each had a mix of 20-cent and $1 coins. Candy had 36 $1 coins, while Lillian had 13 $1 coins. What was the difference in the total value of Mabel and Lillian coins? So in this case, we just want to assume that each person had 40 coins because in the question it says each of them had the same number of coins. So why 40 is because it's a whole or multiple of 10 that's closest to 36 or higher than 36 lah. So in this case, let's calculate Mabel, which is basically if she only has 20-cent coins, so 40 times 20 cents, this will give us $8. Then we can calculate for Lillian. So we know that Lillian has 13 $1 coins. So we can calculate the number of 20-cent coins she has, which will be 40 minus 13. This will give us 27. So that means the total for Lillian will then be equal to 13 times $1 plus 27 times 20 cents. And this will give us $18.40. Therefore, Mabel and Lillian each will have their own total, which is $8 and $18.40. So if you were to get the difference, it's just basically just minusing off from each other. It's $18.40 minus $8, and this will give us $10.40. There you go. Pretty straightforward. You might be thinking, can this work for any other amount? Yes, we can. So if we made each person have 50 coins, then we just calculate. So for Mabel, it's just 50 times 20 cents, $10. For Lillian, same thing. We need to calculate the number of 20-cent coins, which is 50 minus 13, which is 37. That means the total for Lillian would then be equal to $20.40. Since we know Mabel and Lillian, then we can just minus them off. So the difference would then be the same, $10.40. So therefore, since they have the same number of coins, the difference will also the same. In this case, is $10.40. Question 17. There were 16 more students in Team A than in Team B in a competition. 1/4 of the students in Team A and 3/7 of the students in Team B were girls. Number of boys were twice the number of girls in the competition. How many boys were there all together? So for this case, we want to make use of units and parts. Okay, so in this case for Team A, pretty straightforward. We just use the ratio just to visualize a little bit easier. For Team A, since 1/4 of the students in Team A is girls, that means the boys will be 3 in this case. Then for Team B, since 3 out of 7 of them are girls, that means the boys will be 4, right? Pretty straightforward. However, do not get confused that these two number of teams are the same. They are different. Okay. So from here, we know that since team A and B are different, then we can use units and parts. So let's have one unit be number of students in team A. So team A girls would then be equal to 1 unit according to this. Team A boys would then be equal to 3 units. Then for team B, we're going to do the same, right? Team girls will be 3 parts and team B boys are 4 parts. So they are different. Okay, so from the question, or okay, but before that, from the question, it says here that the boys or the number of boys was twice the number of girls in the competition. So the boys was twice. Okay, so like this. So that means we can calculate the boys. So total boys from both teams is 3 units and 4 parts. Then for the total number of girls over here, equal to 1 unit plus 3 parts. Girls is 1 unit and 3 parts. So since they are twice, right, that means boys times of the girls. Since we know the boys, we know the girls, then we can just swap in the equation. So 3 units plus 4 parts, 2 times of the girls. That's what we see over here. And then if we were to find even further, this will be 3 units plus 4 parts equal to 2 units plus 6 parts. Then if we were to simplify even further, we actually can find for 1 unit. In this case, is 2. So then that means we can convert the team A over here to parts because they are using units. So team A convert to parts. That means for team A girls, since they have 1 unit, is 1 times 2 parts because 1 unit is 2 parts. Go 2 parts. Team A boys will then be 3 units multiplied by 2 parts. This will give us 6 parts. Then from the question, it says here, there were 16 more students in team A than in team B. So that means team A minus team B is equal to 16. So we can find the total number of parts in team A. So total in team A parts, okay, is equal to 2 plus 6. In this case, right, team A, 2 plus 6 is equal to 8 parts. Then for total for team B, parts as well, it is equal to 3 plus 4 equal to 7 parts. So from here, since we know team A minus team B is 16, that means it is basically 8p minus 7p, which is 16, and 1p is equal to 16. So from the question, it says, how many boys were there all together? So total boys from the 2 teams over here then be equal to 6 parts from team A, and team B over here would then be 4 parts. So the total number of boys in parts can be equal to 10 parts. Obviously, that means for the total boys, since 1 part is 16, then total boys will then be equal to 10 times 16, which is equal to 160. Right, there you go. So if you like this video, give a thumbs up. If you want more of this kind of video, subscribe down below and comment down what are the things you want me to show you next. In the next one, bye bye.